So now we will study about the three rules, okay, that is needed for the rays, for construction of ray diagrams, okay. After which I will go back to that part so that it becomes easy for you. So for that, first is the ray of light incident at the optical center of the lens passes undeviated, that is straight, okay. Whether it is a convex lens or concave lens, you will see that the ray that is passing through the optical center, it passes undeviated, okay. And next is a ray passing parallel to the principal axis, the incident parallel to the principal axis, after refraction will pass through the second focus. After refraction passes to the second focus. Fine. Same way here also, in case of this concave lens, it is passing parallel, and after that it is deviating here, and it appears to come from second focus, okay. So remember, second focus is the point where it is meeting. So in case of concave lens, it meets this side, so that's why this side is our second focus. And in case of convex lens, this side it meets, okay. Therefore this is our second focus on the right hand side. Clear? And the third rule is any ray passing through the focus point, the first focal point, okay, after refraction will become parallel to the principal axis. Here also, any ray falling on this F1, it appears to fall on this F1, appears to meet on F1. After refraction, it becomes parallel to the principal axis. Clear? So these are the three rules that we are going to use in order to construct any ray diagram of lens, so that we can find out the position of the image. Just like how we have done for mirror, you will know that first we will keep the object at different positions. First we will keep at infinity, then we will keep at a far distance, then we will bring it near the center of curvature, okay, then on the center of curvature, then between center and focus, and after that on the focus, and then between focus and the pole, focus and the optical center, okay. And then we'll find out the different location of the image, where the image is formed and how does it look like. That is the nature of the image, whether it is real, virtual, whether it is upright, erect. We are going to study about it, okay. So before that, we have been given two definitions, that is first focal point, second focal point. Why we have two focal point, I already told you why it is. So first focal point in your book, it is for the convex lens and for the concave lens. Here, first focal point is a point on the principal axis of the lens, so that any rays which is coming through this, okay, any ray which is passing from incident from this focal point, after refraction will become parallel to the principal axis. Here also see, in this it is passing or appear to pass through this F1. After refraction, it is becoming parallel to the principal axis. That's why it is, the definition is given like this here. For a concave lens, the first focal point is a point F1 on the principal axis, F1 on the principal axis, okay, of the lens, such that the incident rays of light appearing to meet, it actually doesn't meet, but these are the two incident rays, and it is falling in such a way that it appears to meet at F1, okay. At it, after refraction, it is falling in such a way that it appears to meet at this point, but after refraction, what happens? It becomes parallel to the principal axis. So such a point is called as F1, as if it is coming from F1 only, correct? So next is our F2, or the second focal point. I told you second focal point is a point where image is formed. First focal point is a point where the the incident rays are coming, like that. If the incident rays are coming from that point. But here for the second focal point is the point where image is formed, okay, is the point F2 on the principal axis of the lens, such that rays of light which is incident parallelly to the principal axis, after refraction will pass through the focus, okay. After refraction, it will pass, refraction from the lens, it will pass through this. So this is our second focal point for the convex lens, and this is the second focal point for the concave lens, okay. Here, any ray which is passing parallel to the principal axis, it will pass through the, appear to pass through the focus after the diverging, okay. You know that In concave lens, it has a diverging action, so it will never meet, but it appears to meet at f2. Clear? So here it is written that after refraction from the lens, appear to diverge from this point. Okay, sorry, not meeting, diverging, because this is a diverging lens, so it will never meet. So appear to diverge from which point? From f2. So that's why f2 is this side and f1 is this side for this concave lens. Clear? Now what is your focal length and what is your focal plane? You understood what is focus, correct? This is the focus. So the distance between optical center and focus is the focal length. Okay, so you have two focal lengths, first focal length and second focal length, because you have two focus. So first the distance between the optical center and f1 will be the first focal length, and it can be written, always remember that the point focus is written capital, but the focal length is always written in small letter. Okay, don't get confused. Next one is second focal length. So the distance from the optical center, distance of what? Of f2 from the optical center, second focal length, okay, is called as this f2. And so this means this is f2, I mean small f2, this is small f2, okay, and the distance here, this is small f1, the distance here is small f1. Clear? Now what is this focal plane? A plane normal to the principal axis passing through the focus is called the focal plane. Focal plane is actually, sometimes the point, the image is not formed exactly on f2. Any ray which is parallel to the principal axis will fall on f2, but like will diverge from this action, diverge from this point, or here it will meet at this point. But when the rays are not parallel to the principal axis but parallel to each other, example this one. Look at this. These rays are parallel beam, but they are oblique to the principal axis. So after refraction, it is not meeting at f2, but it is meeting at a point below f2, which is B. So this dotted line you can see that is passing through f2 to B. This is the normal that is drawn here. Straight line which is drawn here is the focal plane. That's why it is saying here that it is said plane normal to the principal axis. Plane normal to the principal axis. It is normal to the principal axis, 90 degree to the principal axis, and it is passing through the focus. This is called as the focal plane. So naturally, if you have two focus, you will have two focal plane also. So focal plane passing through f2 will be the second focal plane, and the focal plane which is passing through f1 will be your first focal plane. Okay. Go through these notes. These notes are also very important. Here many concepts will be given. Okay. So if the medium of both the sides of the lens is same, its first and second focal lengths are equal. So f1 is equals to f2 numerically. Usually when we say focus, that is the meeting point. It is the second focus. Yes, the object is, the image is formed at focus when we say directly. Every time we won't say second focus, first focus like that, no. So whenever we talk about in lame words, whenever we talk about focus, it is actually the second focus. Okay. A convex lens has a real focus because the parallel rays after refraction actually pass through this point. But in concave lens, the focus is virtual, because it doesn't meet at that point, but it appears to diverge from that point. Okay, so that means it does not actually pass through this point, but they appear to diverge from this point. That's why it is not real but virtual. Okay, only a beam of light incident parallel to the principal axis converges to a single point on the principal axis after refraction through the convex lens. If the parallel beam, that means we are talking about this one. Just now we have read these three lines, no? They are talking about this action. But if these rays of light are not parallel to the principal axis and they are falling obliquely, okay, that time it does not converge at f2, but it converges at a point below f2. That is the focal plane. Okay. Here. The point B lies on the second focal plane where the ray AO through the optical center O of the lens meets. Same here. Here also you can see the ray. It is falling obliquely. Okay, so that's why it diverges from a point that is not at F2 but above F2. Clear? So focal